This is the Open HPI course Linked Data Engineering, Lecture 1, Linked Data and the Web of Data. And this is the first part of the lecture. We will look at the story of the web so far. So, if we look at the web, its predecessor, the internet, it's quite old. As you might know, it's the same year like the first man set foot on the moon. 1969 was the starting date of the internet. And these three guys here, J.C.R. Licklider, Robert Taylor and Larry Roberts, these were the guys who envisioned the first internet. And they did not only envision a network where computers are able to communicate, they even envisioned the web in a way similar like it is really today and like it has developed. And this is really remarkable for a time in the mid or late 60s. So they wrote, for example, here before the first lock-on or before the first network was switched in, they said, we are entering a technological age in which we will be able to interact with the richness of living information, not merely in the passive way that we have been accustomed to using books and libraries, but as active participants in an ongoing process, bringing something to it through our interaction with it and not simply receiving something from it by our connection to it. So they really envisioned the web as an interactive medium, and this is really remarkable for the 1960s. So let's take a look on how the web has developed. The first generation of the web was the internet. And there we had something called computer-centered processing. What does it mean? So it means the central point in the network was the computer. And you had to deal with the computer to get access to the information on the computer. So how did the user get the information? Some of you might be old enough to remember these times when you had to open first a terminal window. So you open your terminal and then you connect to a remote system. Then you have to find out what kind of information is available on this remote system. So you retrieve the file system data from the remote system. Then you scan through the file system data and you see something what you are interested in, and then you download a file from the remote system to your local system. And only when the remote file has been downloaded from the remote system and the download is complete, then you are able to look at the file and read the file on your local system. So you see this is really, really expensive and complicated. So to open a terminal, to connect to a remote computer, to scan a remote file system, you have to be an expert. So you require expert knowledge for that. And of course, if you try to find something specific according to its content, this is pretty complicated because you have to look at each single file that you might find or might come across on a foreign computer. So this is almost next to impossible without something like a search engine. But we know the web and the internet, they have developed. Let's take a look at the second generation. In the 1990s, in the age of the web, everything changed. And the game changer actually was this graphical browser. So a graphical user interface which enables the user to actively interact with the information on the web in a rather simple way. So first of all, it's not computer-centered, it's now document-centered, because all of these documents on the web, they are expressed or written in a markup language which enables the documents to connect to other documents. So in the end, you end up with a network of documents. And the nice thing is you can go across these edges and follow the edges in the network to, like a spider, to go from one place to another. And you can do this, of course, with this nice interactive graphical user interface. So you open your browser, you load a document. For this, probably you need a URI, an address, or a pointer to an address. And then, of course, you read the document, and in the document there are links to other documents, and you simply click on the hyperlink and you follow that hyperlink. And this, of course, is quite easy. So this means information access does not require expert knowledge. Everybody is able to do that. And of course, information retrieval then will be possible with the help of search engines, which enable so-called web crawlers who crawl the web, gather together all the documents they find, store the document in one single great database and make it accessible, retrievable for the user. So without search engines, we would not be able to navigate the web and to find information today. So this is document-centered processing. But this, of course, is not the end of the story. So what's next? Next is the third generation, the web of data. And we are currently entering exactly this age of the web of data. And there, it's not about documents, it's about data. So besides documents, there is also data stored on the web. And data, of course, is stored on the web for a long time now. So the web of data is not a new web, it's simply an upgrade of the web of documents. So what you look at the web is it's the web as a huge decentralized database or knowledge base. And the interesting thing is it's data, so it means it's machine accessible data. Machines can access the data. And if you describe the data sufficiently in a machine-readable way, then machines will possibly also able to understand the data, to make sense of the data, and to use this data for further processing. Tim Berners-Lee, who is the inventor of the original web, already about 20 years ago wrote, "The web of human-readable documents is being merged with the web of machine-understandable data. The potential of the mixture of humans and machines working together and communication through the web could be immense." And this is what is actually happening today. Now, back to our question. How does the user get the information in the web of data? How will things change? So, let's have a look at that. This is one possibility, how you get information from the web of data. You don't have fixed documents anymore because documents will be dynamically created. They will be virtual with the help of so-called intelligent infrastructure services who access the live data on the web. You see here the web of data as a network of interconnected data sets. So this is the so-called linked data cloud. We will come back to that later on. And these intelligent infrastructure services, they access the data, and if the data changes, they see that the data is changing, and of course they take care of these changes and will report it, for example, to a personal assistant who aggregates, who filters and selects and remixes this data to create something like a virtual web page, which is then presented to the user. So this could be one of the many scenarios how you can make use of the data in the web of data. The advantage of that is information now can be automatically selected from the web of data. It can be aggregated, remixed, and published according to personal preferences of the user. And how to achieve this will be subject of these lectures. Okay, let's start with the traditional web like the web is today, and let's have a look at the architecture of the web. Basic building block, of course, in the web is the so-called URL. So this is the address of all the web pages you know. And the more general concept, it's called URI. So the Uniform Resource Identifier is a generalization of the URL, which is the Uniform Resource Locator. So the locator is an address. The URI is more or less a name or an address. We will come back to that later and look into detail. What does it mean to access data, to access information, or to reference things with the help of URIs. But the URL is one of the many building blocks of the web. The next building block of the traditional web is the protocol with which messages are transferred on the web. And this is the so-called hypertext transfer protocol. With this protocol, of course, you can access information which is referenced with the help of a URL, which is then the address of the data or the information you access. And the information which is stored then on the web is expressed in HTML. This is the hypertext markup language. And with a hypertext markup language, you are able to encode information in a way that it can be represented in a web browser on the web, and you can create links, for example, to other documents and all the stuff. So these are the three building blocks, URL, HTTP and HTML, which make up the entire web. And based on that architecture, we will extend it further then to come closer to the web of data with the help of linked data. So we will focus on that in the future of the lecture. HTML, as the main language in which the web is represented, has of course a drawback. The web, of course, is meant for humans, which means humans must be able to read it. Of course, you are looking in your browser and you are reading a document. So HTML describes how information is presented to the user. It describes how information is linked to other information, but it does not describe what the information really means. And here, of course, we will run into problems. So the problem is, what does the information mean? And for example, if you look at the search engine, to get the correct result of what you are looking for, the search engine must more or less understand what you are looking for. And there is, for example, this rather prominent dilemma, this so-called information retrieval dilemma. You look, for example, here for something which is called Jaguar, and you see here you get quite a mixture of results. So possibly you have meant the cat, or you have meant the car, or maybe you have meant something completely different, like, for example, a previous version of this Mac operating system, which was also called Jaguar, but the search engine doesn't know. So the problem with natural language is that you have there a lot of ambiguity. It means the same word can have different meanings. And of course, the search engine or a machine which tries to understand the meaning of your text must be able to disambiguate this correctly. On the other hand, you also have the possibility to describe the same fact, the same meaning with different words. You can use different synonyms for the same meaning, or you can use metaphors. So these two kinds of ambiguities make it quite difficult to understand textual content in a unique way. And this, we will see, is one of the major drawbacks and problems that we have on the web today. And even more, so I give you this little interesting message here. Can you make sense of it? It's difficult to understand. Maybe some of you will remember what it means. But as time goes on and people potentially do not watch television, they will have trouble to understand what is the implicit hidden meaning in that. So who is that Heisenberg? Who can wait and why can he wait? And what's the meaning of all that? So I leave the riddle to you. The point here is that we have also to deal with implicit knowledge, which means information that is not specified explicitly, but must be derived via logical deductions from the other available information. And this, of course, is only possible if you have something like a formal knowledge representation with a logic behind that, so a formal mechanism that is able to make valid deductions. And this, of course, is one of the building blocks of the semantic web and can be applied also in the context of linked data. The problem of the web today is that in the traditional web, there is no explicit semantics. This means, for example, that search engines must be able with, for example, heuristics or with other approximations, somehow try to make use of to understand this content. So they make an approximation of what could be the correct interpretation of the data they are reading. So this is the drawback if there is no explicit semantics. You try to deduce it from the available facts, and then, of course, you make errors. So we will see how to cope with that in the future. For example, in the next part of the lecture, we will take care of how to understand data on the web.